So technically we're just looking for the equation of this hyperbola that's described here, but actually we're going to go ahead and find everything out about it and draw a picture in addition to finding the equation. What we have to go on, it's like a little logic puzzle here, what we have to go on is the location of the vertices. -1, 3, there's 1, and 5, 3, there's the other one. But that actually gives us quite a bit of information. It tells me, first of all, that my hyperbola is going to open left and right. It also tells me where the center is. The center is the midpoint of those 2 points. It's halfway in between. And since they're nice whole number coordinates, we can kind of just look at it and determine where the center is. If we had more complicated coordinates, you could formally find the midpoint using the midpoint formula. But looks like my center is at 2, halfway between -1 and +5, 2, 3. So we got the center. Now that we have the center, we can also definitively say the value of A, which is defined as the distance from the center to a vertex, A is 3. And that's a piece that we're going to need for the equation. The other piece of information that we have is that the slope of one of the asymptotes is 4/3, which actually that means the slope of the other asymptote is -4/3 because they're the same number, opposite signs. But look what else it tells us. The slope, since I'm opening left and right, is B over A. Well, I already knew A was 3, so now I know B is 4. And that's going to let me find the 2 points on the conjugate axis, the 2 endpoints of the conjugate axis, perpendicular to the transverse axis. So from the center, I'm going to go up 4 and down 4. And there are those 2 points. If I know A and B, I can find C. In a hyperbola, C squared equals A squared plus B squared. A was 3. B was 4, so C looks like C has a value of 5. C is the distance from the center to the foci. There's a distance of 5, so I can locate the foci from the center. I'm going to go a distance of 5 along the transverse axis, so the same place the vertices are. And we can say the foci are at, looks like 7, 3, that's 2 plus 5, and 2 minus 5 is -3, 3. We've got the 2 foci. Oh, and since we know the slopes of the asymptotes, I guess we better write the equations of the asymptotes. We're going to have, I'm opening left and right, I'm going to have y minus the y coordinate of the center equals m, the slopes, there's a +1 and a -1, 4/3 times x minus the x coordinate of the center. There are my equations of my asymptotes. Well, we have plenty of information to draw the picture at this point, so let's go ahead and do that. I'm going to have my rectangle going through the vertices and the conjugate axis endpoints. There it is. And my asymptotes go through the center and the corners of my rectangle. There they are. The graph goes through the vertices and out, opens out along the asymptotes. So we got one piece going left, one piece going right. There's the graph. Still need the equation. Here it comes. I'm opening left and right, so my x term is the positive one. I'm going to have x minus the x-coordinate of the center squared over a squared minus, because it's a hyperbola, then I'll have y minus the y-coordinate of the vertex squared over b squared equals 1. And there's my equation.